Welcome everybody to session 2 of using ACPF outputs in watershed planning and implementation. Hope those of you that missed the first session, I hope you had a chance to look at the recording because we went through a lot of good material. I'm going to start with just a little bit of housekeeping stuff again. I want to point you to that participant folder at z.umn.edu/ACPF handouts. There's a folder there with presentations in it. That they're not all there, but we will keep adding them as we get them. The spreadsheet that you saw that we talked about last time is there, where with the list of all the participants and what people are interested in. It's great to see who else is in the room with us. And there's the participants agenda, which has the link to the recording from Tuesday's presentations, and also the email addresses for all the presenters is in there. So if you're trying to track those down, that's the place to look for it. Again, throughout the session today, put your questions into the chat. We'll answer them as soon as it makes sense to. And let's see, Janice Kepka is doing technical support again today. So she will be addressing any issues there. Today, we're going to take a few minutes to review Tuesday's session and do any Q&A. So if you have some confusions and things you didn't understand from Tuesday, now is the time to bring up some of those questions. And then after that, we'll jump into a number of examples of ACPF uses, which I think will really help you get a better idea of what all of that technical information means and how to apply it. This just a few takeaways I wanted to highlight from session 1. The first is that if you haven't looked at the user manual, take a look at that. It's a great reference to look back at, even if you're not a GIS user. Second item, hydromodifying and the DEM and a good digital elevation model and defining the stream network. These are all time-consuming parts of using the ACPF, but they're really critical to getting a realistic picture of how water flows. And it's also pretty critical for getting good results from the other tools. And the other thing, and you'll probably pick this up during our discussions today, you can damage trust with your partners if you start doing something that just doesn't make sense, if the hydrology or something just doesn't look right. So important to get those steps right. If you noticed in that the tools there, Matt spent most of his time on the practice citing tools and how do you cite these practices, but don't overlook the field characterization tools as well. Those parts 3A, B, C, and D, because they can be pretty useful in identifying the high priority areas, where are the areas of concern in your watershed. And there's other ways to use those field characterization tools. There's other ways to use the input layers themselves than just with the ACPF citing tools. So look for, there's lots of different ways to make use of the outputs from ACPF. This, let me back up here. The ACPF is adaptable to a lot of different landscapes, but you heard Matt talk about these different parameters you can adjust, and getting those adjustments right are critical to making sure that it reflects what your particular landscape is about. So you'll need to pay attention to that. And I say that it's not just for the GIS technicians. The GIS specialists really need to be working with somebody who understands the landscape, the field specialists like yourselves, like most people that are in this room today. And so it's a back and forth between the GIS person and the field person. So that look for that, plan to field verify results, plan to go back and forth with the GIS specialist, help them with that. So those were some of the takeaways I wanted to talk about. I'm going to hand over now to Glenn O'Neill and ask him to introduce himself, and then we'll answer a few questions that you may have from Tuesday. Oh, and there were a couple that came back in the feedback, so we'll address that. So go ahead, Glenn.
Thanks, Marcel, and good morning, everyone. As Marcel said, my name is Glenn O'Neill. I work for the Institute of Water Research at Michigan State University. We're a research group that's part of the College of Agricultural and Natural Resources, and we focus on issues of water quality, water quantity, mainly within the Great Lakes Basin. We do a lot of work within agriculture and agricultural conservation. So the ACPF is a tool that aligns well with our goals and the types of projects that we work on. And so Marcel and Kevin, in planning for today's session, asked me to join and participate and address some of the questions that were submitted after the previous day's session. And so I'll go over some of those, but I'll also at the outset say that my email address is in the PowerPoint that Marcel was showing there. And if these future users of ACPF have questions, technical questions, a lot of my background is in GIS, so I can help navigate any of the issues you might have, and some of the questions that were submitted will speak to that. So the first question that came in was how to access the program. Is ACPF already part of ArcGIS? And the answer is no. You have to download it from the ACPF website, and over these 3 days, I'm sure you'll see that link numerous times. But it's pretty straightforward steps on how to download the tools. That's one piece. Downloading the tools and getting it into ArcGIS, and it is available for the different flavors of ArcGIS out there. There's ArcGIS Desktop, if that's what you're comfortable with. You can utilize ACPF within that, and the newer flavor of ArcGIS is ArcGIS Pro, which is the direction that Esri is moving in. So if you're starting fresh, it would be good to start with ArcGIS Pro, because that's where pretty much everything will probably be in the next couple of years. But if you want to work in desktop, it's there as well. And so there are different versions of the download for each of those types of ArcGIS. And within those is our installation instructions on how to get it running. But they operate as independent toolboxes, and the instructions explain how to load that into your version of ArcGIS, and then it's just clicking and providing the inputs. And the help files, the metadata that's accompanied those tools within ArcGIS is pretty explanatory. It mirrors what you'd see in the user guide. So there's a lot of explanation on how to utilize the tools and what the inputs that are needed to run them. So the short answer is no. You do have to do some legwork, but if you go to the website, it'll explain how to do that for whichever version of ArcGIS that you're using. And if you have problems with it, then you can reach out probably to any of the people who participated in this workshop, or myself, and we can help you get it up and running on your machine. The next question that was submitted is ACPF to be used just to show where all possible BMPs are in one field? And my answer to that question would be no. It can do more than just show BMP options for one field. It as will be demonstrated in some of these subsequent presentations today, it's useful in whole watershed planning. It can tell you information about one field and about where certain practices might be. And so if you're working with a producer who's interested in conservation, this is certainly a tool that can do that, but it's not limited to one field at a time. If you're using this efficiently, you're going to be doing this on a larger area with multiple sub-watersheds, perhaps as part of a watershed planning project. And so it can speak to an overall conservation strategy for a larger area than field. And a follow-up question to that was, who are the ACPF technicians? And broadly speaking, I think we hope that everyone on this call is a future ACPF technician, but it does require some GIS base skills in order to navigate the tool, to generate the outputs. And if you're starting from scratch, then it's going to require more GIS skills than if the input database already exists for the area that you're interested in. But that said, to go back to Marcel's earlier point, I think the ACPF technicians are kind of a team of people. They're the field specialists who know the area, perhaps know the producers and know the field and can verify the outputs that are generated by GIS specialists who might be running ACPF. But as you'll see, again, in the later presentations today, I think it's a pretty diverse group of people who are utilizing ACPF, from people like me at a university, people from state government like THAD, conservation district staff, people from organizations like Extension, University Extension, like Matt the other day. And so it's the ACPF technicians is a diverse group. But if you're thinking specifically about who is running these tools, who's using it, a lot of it is going to be people with that are either GIS specialists or utilize GIS in their professional duties. But that certainly doesn't mean it's limited to those individuals. You obviously have to have access to the ArcGIS software to run this on. But if you do, the user guide and the documentation that comes with the tool is pretty user friendly and accessible. And hopefully by attending this workshop, that'll straighten out that learning curve a bit for utilizing ACPF. So those were the questions that we got after Matt's session the other day. But Marcel, do we want to open it up to either submitting in the chat or just asking over their mics any other questions people might have?
Yeah, and I would open it up if anybody wants to ask any further questions. And while you're thinking, I want to ask you a question, and that is, which of the tools that you heard about on Tuesday are you most excited about and seem particularly useful in your watershed and your work? If you want to just put that in the chat, I'd be interested to see which parts of the toolbox people are most interested in. And I think Glenn's point about the GIS technicians or who's running the ACPF is a question that people in each state are answering a little differently. But who does? There's local technicians, there's NRCS people, there's the state. So it's every state is solving it differently. Oh, here's another question. Josh asked, does ACPF work with pasture hayland land use or just cultivated cropland?
Yeah, I haven't used it for pasture land, but in my studying the user guide, that it will provide insights for pasture and hayland in addition to just cultivated cropland. Others who may have experience utilizing it on pasture land can answer for themselves, but that's my understanding of it.
Yeah, I'm trying to remember. Some of the tools differ. Some of them will exclude pasture or hayland if that doesn't make sense for the particular practice. Like a grassed waterway, that wouldn't make any sense there. And so any kind of perennial land use will get excluded. No. Wendy asks.
I see some of the questions coming in too. So right now ACPF only has Lake Erie Basin. I'm interested in Saginaw Bay. What steps do I need to make that happen? That's a great question. So the ACPF website has a link to a map of where the key, not all the inputs, but a lot of the key inputs to ACPF are already formatted and kind of ready to use. The biggest remaining variable for those areas is the processing of a digital elevation model. So for Saginaw Bay, those core databases are not formatted already, at least not through that particular portal where those databases are downloadable. But the ACPF does have tools. It has a utilities toolbox that can help the user construct those databases or those inputs for themselves. It's obviously going to require a good deal more work, but it will do some of the land cover and the soils processing. It'll link to web services that can download and format that data for you. But there's still some, there'll still be the matter of the processing the digital elevation model. And again, I'll defer to the larger group here about the accessibility of the field boundaries, because I know that working in Michigan, I know that the agricultural field boundaries can be a difficult data set to acquire, and I don't know if the ACPF utilities provide any tools in downloading those, because I know their availability within Michigan is limited, but some portions of Michigan do have the field boundaries in those core databases. All right, another question. I'm in California. Some of the practices that are included in ACPF are not widely used here. Are there opportunities to develop new processes within ACPF for other practices? So, yeah, I'm not sure what. I've done a lot of work in California, so I'm not sure what some of those other practices are. I'll say this. You know, the outputs, ACPF doesn't just output, this is where you should put a bioreactor, or this is where you should put a grassed waterway. It has a number of additional outputs that it'll generate that are potentially useful to any conservation program. It'll give you the, I'm drawing some blanks. It'll give you the stream erosivity power of for a particular location. It'll give you outputs of topographic wetness and index. It has a number of surface hydrology and flow direction outputs that are potentially useful to other conservation practices. So that's my short answer. And if you're really good at GIS and you're capable of writing your own scripts, some of those ACPF outputs could potentially feed your own scripting of a particular conservation practice that isn't in it presently. But I know that the group overall, would welcome any input on future practices that people would like to have considered in the tool, and have a running list of those. But that's my answer for that question.
Yeah, I'm going to also encourage you to ask that same question next time to Pam, who is going to be presenting on the National Hub. And she'll talk a little bit about what the plans are. At the moment, they're not developing new practices, but that is something that'll be in the longer term thing. So bring that question up again to Pam. I think that'll be good to ask. Glenn, thank you for taking a few minutes with that. And if people want to keep sending questions in through that feedback form over the coming days, we'll keep working on answering these. At the moment, I realized I had the wrong order of people on the last slide that I just showed you. So I just quick move things around, and this should be correct. Our first speaker this morning is Joe Magner, talking about Beargrass Creek, Indiana. And I think I'm going to just hand off to Joe without further ado, if you would introduce yourself and tell a story.
Okay, Marcel, thank you. Let me pull up my slides here. So should be able to see the slides. Doesn't look like it's quite. There we go.
Looks good.
Joe Magner, University of Minnesota. This is a project that began a number of years ago with the Environmental Defense Fund, working with a conservation innovation grant. And at the time, what we were trying to look at was how do you get a 45% reduction in nutrients down at the Gulf of Mexico, particularly with nitrogen. And we looked at a number of watersheds throughout the upper Midwest and chose this watershed, Beargrass, in Indiana. And for a variety of reasons, which will unfold here as I explain the story here. And so I just want to acknowledge Susie Steffen and Herb Manifold, Sarah Porter, Mark, of course, who developed the ACPF, who's now retired. We were all participants in this project that ran, the grant ran for about 3 years, but actually it extended out to 6 years because Herb Manifold, who was my master's student at the time, then took the job as the Section 319 coordinator, which basically allowed the project to extend a little bit further in terms of getting practices on the ground. So just a little bit of where this watershed is. It's a 12-digit huck within the Eel River watershed in Wabash County, Indiana. So this is probably, you know, for somebody coming out of Minnesota working in Indiana, this was there's a little bit of a learning curve for me. But again, I've been working with agricultural systems throughout the upper Midwest, and so the drainage system here was a little bit different than what I was used to seeing, but nevertheless, the kinds of practices that were applied in terms of corn and soybeans, the type of acres, as you can see, again, it's not a huge watershed. I think what was interesting with the Beargrass Creek watershed is that there were 4 fairly large operators who were on board with really trying to make good changes to limit the amount of nutrients coming off the landscape. And that's really kind of the primary reason why we chose the Beargrass Creek watershed, is because we could see that there was some pretty good local buy-in by the operators, owner operators, who were willing to make some changes. So again, the issue here is nutrients, particularly in a watershed where there was a lot of manure being generated, and taking advantage and accounting for that manure was something that, well, they just haven't quite done a very good job of that. And that was one of the things that Herb was really looking at. And Herb did publish a paper in the International Journal of Hydrology that discusses the nutrient budget that he built to then help go back and communicate with landowners really what kinds of things they needed to do to take a closer look at the amount of nitrogen that was present in their soils. To do that, Herb installed some access tubes. We set up some stream gauge stations. This is just sort of a schematic here of showing kind of what Herb did here in terms of looking at the manure application, looking at the amount of precipitation being added to the system. Part of the area was a tile drain. Some of the area was not. So Herb installed a series of access tubes so that we would have a pretty good understanding of what was going on in the soil in terms of the nitrogen pool in the soil. And then also setting up some gauge stations so we can kind of keep track of what was coming midway through the watershed, as well as what was being exported from the watershed. And this, again, the slide here just shows the location of the access tubes in red, and the 2 gauge stations in yellow. One midway, one at the mouth of the Bear Creek watershed. And this is the work of Sarah Porter. Sarah really was the one that then kind of developed the ACPF for Beargrass Creek and came up with a range of practices that could be applied. And in a sense, this was sort of our template to sort of then bring out to landowners and begin to have conversations. And, you know, in terms of cover crops, Indiana has been one of the leaders in getting cover crops out on the ground. And so you can see already there was some pretty good use of cover crops within the watershed. And of course, that has now expanded since 2015 due to Herb's work and continuing to reach out to landowners and trying to get them to try it. And I think it's been able to catch on because, again, a lot of the farmers that are working and operators that are working in this watershed are seeing what their neighbors are doing and seeing that they're having some success. One of the things that probably wasn't quite as successful was looking at controlled drainage. There were a number of areas within the watershed where that could be applied, but that would have required a capital investment for some landowners to kind of come in, take out their existing drainage system and put in a new drainage system. And for the most part, they just didn't see the return on investment to doing that. And so even though Sarah was able to point out where we haven't had a number of acres to do that, it just didn't happen for the most part. When we look at sort of buffers, there was a number of places where Sarah was able to identify where buffers could kind of go in. And again, that was part of Herb's job, was to go out and meet and eventually convince landowners to sort of do this work. And again, this is based on where we think the water table is. And obviously with any model, with any tool, there needs to be a certain amount of field validation. I mean, the actual location of the water table, and which may be shown on the map here, didn't always line up. And so so that field validation is important to get some of that done before you really start pushing these maps. We looked at sort of two-stage ditches as being an option, and it turned out and in Indiana there seems to be a lot of acceptance of two-stage ditches, and there was at least to my knowledge right now, there's at least one two-stage ditch that has gone into place. I'm not quite sure how it's performing. I haven't followed up with the data on that, but two-stage ditches was included as part of the ACPF output. And denitrification bioreactors were also popular. Clearly, there were some areas that the tile drainage was satisfactory to kind of intercept and then place a denitrifying bioreactor into before that water was then discharged to the stream. And so our story here, or really our approach, as you can see by the title, it's the watershed, and then quotations or following that is the restaurant approach. And the reason I say restaurant is because it kind of, for me, it helps kind of create an analogy of what we did here. Mark and Sarah, particularly Sarah here, was the one that produced the menu or the array of different practices that could be used in the Beargrass Creek watershed. Then Susie and I were really out interacting with folks, with the landowners. Susie in particular was able to sort of make initial contacts. I made regular trips down to Indiana. We hosted a number of meetings, and so initially we really only got some appetizers out there, and that's kind of when you have a first contact with landowners. they're still trying to get to know who you are and you know, do you have credibility? But as time went by with this project, others were able to kind of step up and kind of order a full meal. In other words, more than one practice, a practice where some stacking could take place and you could see sort of some multiple benefits of one practice stacked against another practice. And so the point of this slide is simply that this is not a McDonald's drive-through type of approach. This is really to kind of really get practices out there. It does require a little bit of time of sitting down and looking at the menu, interacting with farmers on more than one occasion so that they can have time to sort of think about and digest the information that you're presenting to them. And so don't expect to really kind of get something on the ground and a commitment from a landowner right away. And again, I'm probably preaching to the choir, and I think probably a lot of you know that. But I think, you know, in this particular situation, because Herb was able to, after he finished his master's degree with me, go back and work as the 319 coordinator. He was able to then kind of be the chief chef, if you will, and then, you know, kind of put together, you know, these more detailed farm plans and figure out how to take 319 funding, mix it with other funding to really kind of get some products out on the landscape above and beyond the Conservation Innovation Grant time period that we were working on with this project. And so again, just to iterate here, you know, we had a number of landowner meetings. Two of them were, as you can see in the photo here, where we brought everybody that was willing to come together to a meeting and really talk about the watershed, talk about what we were trying to do, not only from the Gulf hypoxia goals, but also really down to, you know, what could be the return on investment if you do some of these practices on your own landscape in terms of maybe some less commercial fertilizer application and more strategic application of manure. And as part of this project, Purdue University also, through their social science program, they were evaluating and looking at how this whole process was playing out. And so they did produce, Sarah Church did produce a publication that shows kind of how the social science of this whole project went down. And because they were looking at everything we were doing, from the large meetings to the more intimate one-on-one types of meetings that we had to the follow-up practices that ended up going on to the landscape. So it's, you know, here's an old gray-haired, gray-beard guy out there, but I couldn't have done anything, even though I've been in this business for 44 years. I don't have any credibility until somebody like Susie goes out and working in a tag team here. We can kind of begin to talk about, well, what could you do on this landscape? And as pointed out earlier, understanding the landscape and getting the hydro conditioning right is critically important to developing your credibility with that landowner. And because if you're going to be talking about something, maybe even something outside of the box, the landowner is going to have a sense of whether you're giving them BS or not. And so, and because I've spent a lot of time looking at different best management practices and practices that are a little bit outside of the box, we were able to talk about things like oxbows, which I'll get to here in just a few slides. So in the end, I think what most of the landowners were willing to try, other than, you know, trying to reduce their commercial fertilizer and do more strategic planning with their manure application, they were willing to try two-stage ditches, denitrifying bioreactors, and stream channel modifications that allowed for the utilization of old oxbows. Now, you may wonder, well, what is an oxbow? Well, on this slide here, you can kind of see the red areas associated with the mainstream of Beargrass Creek. And these red areas do represent opportunity areas where if we can take water coming off the field, or if we can take water that's under a flood stage and get it back into some of these oxbow areas, they're rich in organic carbon. And depending on the residence time, what we have been able to observe is some reduction of nitrate. And Keith Schilling has documented this down in Iowa now. He's got a publication out that shows the value and power of denitrification using oxbows in streams. So yeah, again, oxbows are kind of created as a result of some changes either in climate or the changes in land use that result in cutting off sections of the stream that then shorten up the stream and then kind of leave these sort of natural linear shaped wetlands that are on the landscape that are really not, they're not being used for farming. And so can we make some good decisions about, where we think we can utilize some of these parcels of land within the watershed that we don't think maybe have value, but actually do have some value. And so that this was a practice that I don't think folks were thinking about, but part of my background is in fluvial geomorphology. And so introducing some of these ideas to some of the landowners was one of the novel things that took place within this project. So with that, I can stop and take questions. This is, again, my email address right here. And then Susie Seffen, if you want to get more from a local perspective, her email is down below there. So I'll hand it back to you, Marcella.
Thank you, Joe. Lots of good stuff. One of the scenes I really like in that whole story of Beargrass Creek is putting these large maps in front of groups of landowners to gather around and discuss and sort of talk about the landscape together, and that how empowering that can be to get that group understanding, okay, what are our options, and discuss those together and have some back and forth amongst themselves about what's the good ideas around here.
Yeah, that was one of the things that was, I think, really interesting to see, is that the level of engagement, the fact that they were, again, there were some core individuals that had already been cooperating in terms of conservation practices, but they were able to encourage some of their neighbors to show up at the meeting. We could roll out the big map that Sarah had created, and they could sit there and look and talk about this amongst themselves. And yeah, I think that was powerful. It really, it gave them a chance to look at the bigger picture of what was going on. And then as we followed up with individual meetings later on, I think we were able to sort of make some headway in terms of what people were willing to think about in more detail.
Any questions or observations for Joe? Okay. Well then, I will, Joe, thank you so much for taking some time with us this morning and sharing that story. And at this point, I will switch over to Kevin Kuehner from the Root River, or from the Minnesota Department of Agriculture, but working in the Root River watershed of southeastern Minnesota. So Kevin, do you want to check if your microphone works?
Yeah, hey, good morning, Marcel.
Great, you are good. do you want to share some slides? Oh, and also Kevin shared his slides and also a handout that he's going to talk about that I put into the presentations folder if you want to take a look at that.
All right, I'm trying to share my screen.
Looks
Is
good.
that okay? All right, and we'll try to start my video here too if I can. All right, well, hey, good morning, everyone. Yeah, I appreciate the opportunity to talk about this project. So yeah, so this project, this case study that I'll be sharing is taking place in southeast part of Minnesota. And to kind of follow up to Joe's presentation, this is a little bit different in terms of our approach on this, in terms of the scale, especially the scale that we're working at, and I'll kind of touch on that. And but kind of our approach was more of a one-on-one approach in these small targeted watersheds, and kind of explain how we used walkovers, field walkovers, to kind of along with ACPF to kind of start the conversation with farmers and landowners about targeting specific areas on their farms that we consider to be high runoff risk areas. So kind of our approach was, like I said, was to really prioritize and focus on what we call high runoff risk areas or high concentrated flow areas in small watersheds using ACPF and other tools. We had at the time, so we did this back in 2015, we kind of started this process. So it was, we're kind of in the early stages of testing and evaluating ACPF, working with Sarah and Mark and Dave at Iowa State on this, and ARS. We were fortunate to get a student worker to kind of help process a lot of this at the time and kind of work through some of the bugs that we were experiencing and kind of help provide some of that feedback to that group. We also contracted a field specialist to who's basically a retired SWCD technician to actually go out there and just kind of start these conversations, try to get as many projects lined up as we could using kind of what we call this batch and build approach, and then using field walkovers to implement that. We used a variety of different state, federal, and private cost share. And this was administered by local SWCD, NRCS, and Board of Water and Soil Resources. And so part of this project is, a lot of it is on continued monitoring to see if this kind of targeted, focused approach in these small watersheds is going to move the needle, so to speak, with regard to water quality performance in these small watersheds. So this is the study area that I'm focusing on here in the southeast part of the state. It's located in the Root River watershed in the very far southeast corner. And this is in what's called the driftless area of the upper Midwest. So this is a little bit more detail of this watershed. It's the Root basically drains to the Mississippi. And it's a very complex watershed in that we have unique farming systems and landscapes and geology. To the west, we've got glacial till, which benefits from subsurface tile drainage. In the middle, we've got karst, and then as we get closer to the Mississippi, we have much steeper topography and more mixed with forest land areas. And so what we did back in 2009, this is a part of a special research and demonstration project to evaluate the effects of conservation practices. So what we did is we targeted these small sub watersheds within each of those unique landscapes, and nested within each of those watersheds, we had some edge of field monitoring taking place, both in tile and surface runoff. And then at the outlets of these watersheds, some monitoring equipment as well to measure what's coming out of the streams. So it's a pretty intensive monitoring. It's a long-term project. and something that we continue to do today. And so we are now going to be starting our 14th year in terms of the monitoring going on in these little tiny watersheds. Watersheds are about no more than 5,000 acres each in terms of scale. So just to kind of highlight, some of the things that we found during that study, and really what helped guide the process in terms of implementing practices and kind of the approach that was used. The two things that we really kind of highlight with the data are what we call high risk time periods and high runoff risk areas. And I'll talk about the high risk time periods in terms of what we've been finding for our results. And these are data, this is a 12-year average from 2010 through 2021. And when we look at the field scale, what's really interesting in the data and what we find is that about 25% of the runoff coming off of these fields in May and June produces a really disproportionate amount of that nutrient and sediment loss. And we find that 25% produces 50 to 75% of our nutrient and sediment loss and surface runoff in just those 2 months alone. When we kind of scale that up and we look at the small watershed scale, we find a very similar pattern there, where about 30% of the runoff produces about 45 to 62% of the nutrient and sediment loss. And when we did a special study looking at pesticide loss as well, and we found that those 2 months alone accounted for almost 90% of our pesticide loss coming out of those small watersheds as well. So again, it really highlights those 2 months as really being critical, and a lot of that has to do with the timing of the rainfall events. We have more antecedent moisture. We tend to have more intense rainfall events, and we tend to have the crops not at canopy, so we are more vulnerable to some of that runoff at that time.
Hey,
The
Kevin,
other thing,
this is Janice Kepka from behind the scenes here. I'm wondering if we could just ask you to hide that dialog box at the bottom of your screen.
oh sure, sorry about that.
Thank you. Yep.
One other thing that we highlight with the data, what we found over the last 12 years has been high runoff risk areas. So those areas of a field or a watershed that yield a disproportionate amount of that sediment and nutrient loss. And kind of a classic example that we have, especially in Southeast Minnesota with some of the topography that we have, is a common kind of visual thing that we can see are ephemeral gully erosion areas. And our data, it's really interesting. We had some of our edge of field monitoring that we did. We had really kind of helps emphasize the importance of addressing these ephemeral gullies. We had a kind of unique opportunity to actually measure and quantify the amount of sediment coming out of one of those systems. And this was a situation where we call field 4, and both field 4 and field 2 were managed for continuous corn silage. What was interesting though is field 4 had an ephemeral gully form at about year 3 into the study along an existing grass waterway that wasn't functioning the right way. And field 2 was managed very similar. It had same land use, same soils, very similar. But in terms of the cumulative sediment loss, we found that field 4 had basically about 2 to 3 times more sediment loss off of that field over this time period. So it really kind of highlighted again to us just how important it is to really try to address those ephemeral gullies, because in many ways those ephemeral gullies act like conveyor belts in terms of the efficiency of removing sediment and nutrients off of the field and delivering it off-site. So with that in mind, and kind of using that as a basis for kind of the next phase of this research project, is our goal was to truly try to identify those areas and work with those farmers to address those critical runoff areas and also at the right time. And so using ACPF, kind of the two tools that we used that we found were really useful for us was the stream power index. And then the other one was the runoff risk output. And the runoff risk output is a very simple, but I think a very powerful tool in the ACPF, in that it's a function of distance to stream and the slope of that field. And a very basic, but I think again, very, very valuable tool that we can use. The stream power index is very, very valuable, especially for targeting those concentrated flow areas and those areas that may need a grass waterway or some other type of supporting practice. Joe kind of mentioned, the importance of kind of validating this in the field, and we did a lot of that work prior to this project. And this is just some aerial photography, kind of just showing some of that where we're experiencing ephemeral gully erosion on this field, and we also that was documented, and one of the outputs from the ACPF showed us that that was a very critical field in terms of that runoff potential risk. So with all that in mind, kind of what we did is we got together as a group, and we spent about 2 years trying to discuss, what's going to be the best approach in these small watersheds to, get the conversation going with landowners and farmers to address some of these critical areas on their fields. And so what we did is around the same time, actually, a group in Wisconsin, Discovery Farms, the Discovery Farms group of Wisconsin, was also working on a similar project over in the Jersey Valley area, and they produced a really nice document called the Field Walkover Guide that kind of describes this approach of really going out there and going field by field and identifying some of these areas in the field that may produce more runoff. And so really what a field walkover is just like a field level visual assessment of erosion and erosion potential. But not only that, it's also an inventory of the existing practices that the producers are using and the quality of those practices. So we kind of use that similar approach and did that in these small watersheds, along with kind of using the tools and the outputs from ACPF. And this picture here, this is a picture of Ron Miners, who was hired to kind of help do this part of the study and or help with this part of the study. And he was hired to work one-on-one with those farmers and again start those conversations about where to maybe get some of those practices on the ground. And Ron, Ron is kind of, his background is he was a retired soil and water conservation technician for about 25 years, and so we were fortunate to be able to kind of get him as a part of the partnership to help with this effort. And this is also a picture of one of our farmer leaders, Kent Dornick, who's kind of one of our edge of field cooperators as well in the Crystal Creek watershed. And this is Ron basically kind of going through some of these maps with Kent and kind of getting some feedback from Kent about what he thought was important or what he learned from that, and just kind of getting that important feedback from Kent and this producer, and just understanding what what things to really highlight when we start to branch this out to other farmers in the watershed. This is kind of just a little bit of the steps that were involved in terms of that walkover approach and that walkover process. I'm not going to go into a lot of detail here, but just kind of wanted to highlight a couple of things in terms of where ACPF kind of followed in. So if you look at kind of this 10-step process, ACPF was basically at number 2 in terms of that process. Kind of the first step was developing the relationships and building that trust with some of our farmer leaders in each of those watersheds, and then kind of developing an advisory team and getting feedback and input from that team. Another, I think, a really important step in all of this process was we had the farmer leaders actually send the letter out to their neighbors, encouraging them to participate in that field walkover process. And I think that was really important for us. And it wasn't a letter coming from any agency or organization. It was actually coming from the farmers that lived in that watershed. And I think that was a very important step in getting the participation that we did when we kind of moved into that field walkover process. We also, a lot of the feedback that we got when we kind of tested this out with some of the farmers was, try to keep it as simple as possible. And, I think a lot of the farmers really relied on the input from Ron and kind of his technical experience and background. But it was also nice that they got kind of a really simple 2-page summary of what was kind of found during that walkover approach. And really, we kind of highlighted some of these main topics, which is just highlighting some of the beneficial practices that the farmers were already using, opportunities for improvement, and then kind of just summarizing, how many practices that were identified during the walkover, and how much would it cost, and then which of those practices were considered to be a kind of the highest priority, and which ones should be addressed, sooner than later. And if you want kind of more information, there's a little short video that highlights kind of the approach, and some testimonials from farmers that went through this process. And there's also some interviews with Ron, and kind of the approach that he used, and how he went about kind of doing some of these walkovers with the farmers. So did it, what were some of the results, I guess, from the walkover approach? So we did have really good participation. We had about 100%. We had 100% of those farmers within those watersheds participate. So it was about 50 farmers, and that participated. It basically allowed Ron to go onto their farms and do this walkover assessment. Ron used those walkover maps, some of the ACPF maps in that walkover process, to really kind of help him focus his attention on some of those high priority areas, and really focus on those, and in those discussions with the landowner. And through that, Ron had identified about 400 potential projects in those 3 small watersheds. But really, when you kind of look at it, uh, and this is where using the combination of the ACPF tools and the maps from that, and then also some subjectivity, based on Ron's experience, doing a lot of these practices and putting them on the ground, and also, what the landowners were willing to do, we kind of prioritized and found that about 25% of those were considered a very high priority. And especially with regards with some of their runoff risk, and some of the observations that were made during the walkover, that those should get fixed within the next 1 or 2 years. What was also interesting, we found that about 30% of what were considered those high priority resource needs were practices that the farmers already had in place, but the practices really weren't functioning the way they should be, and not really performing the way they should. And so in our view, that was kind of really the low hanging fruit. And I think for our producers and landowners, they felt like, yeah, let's tackle those first, because it's really not taking anything out of production or any more out of production. Let's just fix what we already have. But by and far, what we found in these watersheds in southeast Minnesota, the biggest kind of resource need that was out there, either a need and or a fix, kind of followed into kind of 3 categories. Number 1 would be grass waterways, especially in those concentrated flow areas. Getting back on the contour, and then maybe reducing a tillage pass, and then also opportunities for grade stabilization, either at the outlets of those waterways, or near kind of the cropland ravine interface. And then also maybe opportunities for perennial vegetation in kind of targeted areas. So, so after the walkovers, Ron, and then kind of the partnership of the local SWCD and NRCS, and other partners, through basically about a 3 to 5 year process, worked with those farmers to kind of tackle those high priority resource needs. And within about 3 years, 70% of those farmers that participated in that walkover added additional targeted practices on their fields. And again, this was definitely a direct result of that walkover process, and those conversations that were had with those farmers, and also some of the maps that were used in those conversations. What was really interesting too is that about a third of those farmers address all of their resource needs. And so that was kind of going above and beyond what we were kind of asking them to do. We asked them to try to tackle at least 1 or 2 of those really high priority needs, at least the first couple of years. But um, about a third of those farmers say, hey, while we're at it, let's just go ahead and just take care of all these at one time. So that was really, really nice to see that enthusiasm. The other thing that was also interesting is that even with cost share, when we were able to get both federal, state cost share, which fortunately on many of these projects, we were able to boost the cost share rates up to about 90%. It wasn't in all cases, but that was kind of the goal, was to try to get that cost share rate as high as possible, but getting it to kind of that target goal of 90%. But even with that, what we found was that some of the farmers, and especially some of the practices, didn't want to kind of um, use some of that money, some of the public cost share dollars. They felt like they just want to kind of fix it on their own and work, just get some of the technical advice, but just work with their local contractor and get some of those practices done on their own using their own dollars. The other thing that's, I think, really kind of interesting too as well was that we found that that initial $50,000 investment for that field walkover specialist, which was Ron, um, to do those walkovers, that end up producing about 1.8 million in terms of cost share assistance dollars, in those small watersheds. So Ron was able to line up a lot of projects in a short amount of time, and fortunately we were able to kind of have both the state and federal dollars available to leverage and make that cost share available to those producers. So these are just some pictures of some of the kind of the key practices that were put in these small watersheds. Again, like I said, grass waterways was a really popular and one of the most commonly used practices that these farmers are already using, but also a very popular practice that they're willing to adopt. And of course, if we're going to kind of focus on these concentrated flow areas and address some of these ephemeral gullies, of course, grass waterways are, a very important tool to help with that. Grade stabilization structures was another big practice. Another one that we've really been highlighting the last few years in this effort has been targeted prairie strips along edge of fields and other kind of high runoff risk areas. And so using the CP43 and CP42 through the CRP program, that's been something that's been promoted, and farmers have been, yeah, open to adopting some of those practices in those areas. A fair amount of feedlot fixes also took place, and then kind of fixing some existing structures that were out there. One of the most interesting ones was in our Bluffland watershed. This was just showing again, that runoff risk output from ACPF, and this one particular field showed up as being one of the most critical in that watershed because of the steep slope and the proximity to the stream. And so in those conversations with the producer, the local soil and water office kind of laid out a variety of different options for them. And what they end up going with was that the farmer basically put in some grass waterways and then also some grade stabilization structures, but then also enrolled the field into CRP for 10 years. And so when that field does come out of CRP, now that a lot of those practices have been installed, it can certainly be, much more resilient in terms of addressing some of the runoff concerns on that particular site. This is another map just kind of showing in one of the study areas in the till landscape in the upper part of the watershed where a lot of those efforts were taking place, just kind of showing the results from targeting some of those high runoff risk areas. And before the project started, about 8% of those high runoff risk areas were considered treated. And then after, some of those really focused and targeted approaches and work, that jumped up to 66% of those high runoff risk areas being considered treated. And those farmers primarily used grass waterways, some prairie strips, and there's a hayable buffer program also that was made available to them. And to some degree, but not as popular, were water and sediment control basins. Part of the challenge that we had in this particular watershed was just the cost with some of those practices to be able to get an adequate outlet with tile on those particular practices there. And just to kind of wrap up, some of the things, I think the lessons learned that we had from this was that it definitely takes a lot of time and effort to build those relationships. But if you can do that, I think it really certainly helps to pay off in the end. And I think what was really important in these particular watersheds was having the great leadership from our farmer leaders that were really the champions of saying, hey, let's move forward with this. We know where these locations are. Let's get them fixed. And so I think that was really key. I also think, what we learned as well was that even though these were small watersheds, we did drum up a lot of projects in a relatively short amount of time, and that um, which also can cause some strain on that local SWCD or NRCS office if there isn't enough staffing there to take care of all those needs at one time. And I think it kind of highlights this idea of, we have really kind of two different conservation delivery models, at least in Minnesota right now, which is, we have the conventional approach, which is kind of these random acts of conservation. Farmer or landowner comes into their local office and says, hey, I have this resource need, let's get it fixed. Versus this other approach where you're kind of flipping it around and having staff go out and really actively selling these practices and having these conversations with producers. And I think you definitely need both of those. But if you are looking at kind of more this precision conservation delivery model, using tools like ACPF and these other tools that are out there, it's really important to recognize just how much and how important it is to have that really high quality customer service, because a lot of this really requires a lot of frequent interactions, and it's really paramount, I think, in that conservation delivery model, that latter one, to have that. Again, very time and people intensive, and that can be challenging, in terms of how do you scale that up, to larger watersheds, and that's something that we continue to talk about, and how do you do that. But I think having that dedicated field specialist in our case was really critical to making this work. Ron was able to just devote all of his time to this. He was able to get out there on a Saturday or a Sunday and provide that really high quality customer service to those farmers and make it really as easy as possible to get those practices on the ground. And ACPF, in terms of that tool, was really, really valuable to us, because I think really what it did is it helped us really prioritize. And we may know where some of these areas are just through kind of some of the other tools that are out there, but I think it just helps us kind of build that confidence in terms of, yep, these are the areas we really need to focus on. And then again, in those conversations with the producers, kind of give them the confidence that, yes, if we do this, these are the best areas that are going to make the biggest difference, or at least have the best potential to make the biggest difference in the watershed. So with that, I will conclude, and yeah, if there's time, be happy to address any questions.
Thank you, Kevin. Yes, certainly if people want to either speak up or add their questions to the chat, that would be great. I really like the observation there again, that there's no shortcut to building relationships and just having good, solid technical background behind you and financial support and so on. But what ACPF brings to it is you can focus that work so that your walkovers or your conversations are focused on the right places and the right practices. The other interesting thing I liked about what you're talking about is how you use that high risk map as a tool for tracking your progress, and that you could point to that as going from 8% to 66% treated. Seems really, really striking. And so to have that as a tracking tool seemed pretty effective. Any other questions or thoughts or observations from people? Has anybody else tried this kind of a walkover approach and this precision conservation approach, whether it's with ACPF or not? Okay. Well, Kevin, we do have a feedback form that we give people, and so yeah, Bree, where are you, by the way? Which state are you in?
I'm in Newton County, Indiana, so we're in the
Okay.
Kankakee watershed, and we also have the Iroquois watershed where it meets up in Illinois. But yeah, our main focus right now is on the Kankakee, and actually our area just received an RCPP to do a lot of work in the Kankakee watershed. So we're really looking forward to utilizing the ACPF in our efforts.
Good. Great. All right. Well, at this point, I will turn this over to Thad Cleary. Now that the last two presentations from Joe and Kevin really have a long history of using ACPF in those areas. Thad is going to talk a little more about Michigan and the plans and what's underway in conservation planning there. So go ahead, Thad.
Thank you, Marcel. Is my presentation up in presentation mode?
Yes, I realize I was muted there.
No, thank you. Morning, everyone. I'm glad to be here. My name is Thad Cleary. I'm with the Michigan Department of Environment, Great Lakes and Energy. I work in the Water Resources Division, the non-point source program within the Water Resources Division. So in our program, we provide grant funds for the development of watershed plans, and then 319 implementation funds or state dollars as well for implementing those watershed management plans. And that's where I kind of want to start this presentation, is kind of talking about that and how we got to this agricultural inventory process that we developed in our program, and then show you how the ACPF is a component, how we've built the ACPF into a component of that process as well. So we've been paying for the development of watershed management plans for 30 years or more. And what we kind of realized quite a few years ago was that we were spending a lot of dollars, spending a lot of time giving these grants. You know, usually in agricultural watersheds, most of the time it's conservation districts that receive our grants. And we'd be spending a lot of time and dollars. Most of the time it takes 2 years. And we'd end up with watershed plans that basically said after 2 years, you know, they need to implement nutrient management and filter strips and cover crops and no-till, but not really where are those practices needed in the watershed. And it really, you know, we could have told you after looking at the land use after 2 weeks that those were probably the practices you needed based on the land use in the watershed. So that's when we began developing this agricultural inventory process. And then the other part of it was, so when those plans were done and it came to implementation, it was kind of like, you know, you put out news articles, you send out newsletters, you send out whatever to just to let people know that you have money to implement these practices. And so it was just basically you're getting those farmers, those landowners who are interested are the ones that are going to contact you to you know, about installing practices. And I think, you know, we've all heard and seen studies over the years that it says, you know, a majority of our pollutant loadings come from a very small percentage of our land base out there. And so that's where we kind of went with this process, is trying to collect information, including figuring out what are the natural field characteristics out there of the cropland, along with how is that field being farmed, to identify which fields have the greatest potential to contribute sediment, nutrients, and pathogens to surface water. And so this kind of gets to what, you know, Kevin was mentioning earlier as well. So with that process, we basically developed this 3-component process, starting with the ACPF, and then there's a desktop component, and then there's a field inventory component. So the ACPF process, you know, Marcel mentioned it earlier, there's those field characterization outputs from the model. And that's what we're really using those to help identify where are those priority fields. So the big one of those is being the slope. What are those? It gives you the individual slopes of those fields, so you have a good idea of which fields are steeper and what is their proximity to surface water bodies, and more likely for runoff. And that's going to also identify then where those practices are, like grass waterways and such. So the slope is a big one. The runoff risk is another one that, you know, we looked at as well. So then from there, we do a desktop analysis. So we have all those field boundaries that were digitized for the ACPF tool. And so then we look at which of those fields are, say, within a certain proximity to surface water bodies. Take 50 feet, for example. So we go through and attribute every field that is within, say, 50 feet of a surface water body. Then we look at aerial photographs, identify which of those fields within that 50 feet, which of those have a planted filter strip. So not just a natural buffer, but where the farmer actually went in and put a grass vegetated filter strip between the crop field and the surface water body. So we know which fields have filter strips and which ones don't after reviewing the aerial photos. And then because I'm with Eagle, we actually permit the CAFO operations in the state. So we actually have the information from the CAFO operations of where they will potentially spread manure on any given year. So we're able to put that attribute, those fields that have the potential to receive CAFO manure. The one thing I will point out there is the CAFOs are allowed to manifest their manure, give it away, or sell it. And right now we don't have that information. That's something that we're hoping to have that in when our new general permit comes out. So if we're able to get that, we're going to have even more information on where that CAFO manure is going. And then in addition to CAFO, it's not just looking at CAFO operations, it's looking at the small and medium operations. So going through the aerial photographs, identifying where those operations are located in the watershed. And then as you're doing that from the aerial photos, is there information that you can see there that will, you know, show operations that may have a higher risk of runoff or pollutants, such as, is there a feedlot you can see that looks like it potentially runs off to a ditch or a stream? Is there livestock access? Do you have a smaller dairy operation that has no manure storage, which means, you know, they're spreading probably manure in the winter because they don't have the storage capacity, and also then what's happening with their milk house waste if they don't have any liquid manure storage on site. So it's identifying that. You can identify a lot of that through aerial photos as well, and then you can also ground truth that later on. So then that gets to our third component, which is actually the ground truthing process, and it's the field inventories. So in this case, we have in our grants, the conservation districts will go out and it's actually driving the watershed. We developed a collector app to actually collect all of this information for each of these fields. And so they will go out in the fall after harvest is completed, after all tillage practices are done. So this usually here in Michigan, that usually doesn't start till sometime in December, could be later if it's a late harvest. And you can do this process, you can do this in January, February, March, all the way up until the following spring when they start doing tillage in the spring. Obviously the snow can't be on the ground to see it. So they will document what the crop was grown, the previous crop there. Was there any tillage done in the fall? Was there cover crops planted? If they saw fields that had manure applied to them, they would document that. And so the thing we're really getting here is by documenting the crop and the tillage practice, you really have a good idea of how much residue is out there, left out there over the winter and early spring. If you had corn that was harvested for silage and it was chisel plowed, you know there's pretty much no residue left out there over the winter at all. Same with soybeans, not a lot of residue left, and if it was chisel plowed. So we get a good idea of kind of which fields are at risk, and we're also documenting what crops are being grown as well as what tillage practices are being grown. And then in the spring, those conservation district technicians will go back out again and drive the watershed, and they'll do this after the crops are planted. Usually you want them up a little bit so you can document kind of what crops are out there for that spring, what crops were planted, but then they'll document how much residue was left after planting. We pretty much use, we document whether it's greater or less than 30%, kind of that NRCS cutoff line for controlling soil erosion. And then we also document which fields have zero residue left, or if they were planted with no-till. The no-till, we know those fields are going to be over 30% residue, but we just want to document how much no-till planting is actually occurring in these watersheds. So then from there, the whole concept is to take that information and trying to identify those fields with the greatest potential based on the natural characteristics, a lot of that information that you get out of the ACPF tool, the slopes and such, the high risk runoff, and then how are those fields being farmed and what is the risk based on that? Because you could have some high risk fields, but if the farmer's using no-till and they're using cover crops and they have filter strips, it's probably not a high priority field, at least from a soil erosion perspective. So this is just an example in one watershed. You see there was 526 fields in this watershed, a little over 24,000 acres of practices. So we went through just looking at the different attributes that we've collected on these fields. And in the first set there, the red priority fields, we looked at fields within 50 feet of a surface water body. And we looked at what the tillage, if they had tillage done in the fall on them, if they had low residue numbers in the spring. And we also identified ones that had CAFL manure, the potential for CAFL manure applied to them. So we ran kind of that scenario, came out with those fields. Didn't give us as many fields as we wanted. We wanted to identify the highest priority, somewhere between 25 and 35%. So then we went back and looked at fields within 300 feet that had slopes based on the ACPF. Their mean slope was greater than 3%. And then again, we looked at the tillage practices, those that had tillage done, those that had the low residue numbers, the CAFO potential, and we identified additional fields. And we got up to somewhere around between 30 and 35% of the fields identified as high priority. And I will say this is just one example, and I'm not even sure it's the best example of how to use all of this information. The actual hard part is with all the information we have is trying to figure out how do you use it to really prioritize these fields. But that's the goal. That's what we're trying to do with all of this information. And it's not just crops, it's taking those livestock information that we've documented where they're located, which ones may have some risk. So we're identifying those sites potentially as well that may be at a higher risk, as well as knowing, there's no aerial photos, the ACPF tool isn't going to get it. You're not going to get knowing what nutrient management practices are happening out there. You can't see that by driving by. That basically takes a technician one-on-one working with the farmer and talking to the farmer about what are the nutrient management practices that they're using. So part of this, so for the Western Lake Erie Basin, the Environmental Working Group had an Herb Foundation grant that they actually digitized all of the crop fields in Michigan's portion of the Western Lake Erie Basin here. They ran the ACPF tool on 13 Huck 12 watersheds. And they also identified using aerial photographs all of the locations of livestock operations. And they estimated based on barn size, they estimated what type of livestock were there, how many were there, how much manure is generated, and how much phosphorus is generated in that manure, and what would be the land base that would be needed for crops to agronomically utilize that phosphorus. So we have a lot of good detailed information on where the animals are, but also if you're going to have fields with higher soil phosphorus levels, more than likely they're going to be fields that are receiving manure applications. So we have some idea on where those livestock farms are, and fields that are in proximity to those operations are fields that may have higher soil phosphorus levels in them that could be posing a higher risk. So that's kind of just a quick run through of how we're trying to utilize the ACPF in this ag inventory process. Here's just a slide that kind of shows where we're at in the Western Lake Erie Basin of doing this process. We have the watersheds up there in the light green and brown in the northeast corner of the watershed. There's currently a watershed management plan being developed by the conservation districts in those watersheds. And so the ACPF is being developed in all of those, as well as the field inventory and the desktop analysis components will be done in the brown watersheds there as well. And then the darker green ones, there are the ones that the Environmental Working Group ran the ACPF tool on already for us. So we have the information there for those watersheds. The oranges colored ones, the 4 of those are where the ACPF is completed and the conservation districts are in the process of completing or have just completed the rest of the ag inventory process. And then the 3 lime colored ones, the Lime Creek, Covell, and Silver there in the southwest part of the watershed. The complete ag inventory process has been completed. And actually the Lenawee Conservation District is going to be just received a 319 grant that just started this past week. And they're going to be using this information to hopefully help them identify what fields, go out, start talking to those farmers and landowners about those practices and using the ACPF information for each of those individual fields when they're talking to those producers. And this kind of gets to a question that was a little earlier that was asked, about the Saginaw Bay and where we're at in Michigan. So the LiDAR is available for all 83 counties in Michigan. So we have that. The ACPF databases have been developed for 113 subwatersheds in or within proximity of the Western Lake Erie Basin. That's what was done by the Environmental Working Group. We have run the ACPF tool in 24 Huck 12 watersheds within the state. 19 of those are in the Western Lake Erie Basin. And we're in the process of running the ACPF tool in an additional 24 Huck 12 watersheds, 8 of those in the Western Lake Erie Basin. Those outside the Western Lake Erie Basin are all tied to watershed planning grants that Michigan's Non-Point Source program is funding. And they're doing the entire ag inventory process in those sub-watersheds as well. The question earlier about Glenn had talked about the common land units. Basically, you need to have the crop fields digitized. We do have access to the 2008 common land units, the field digitizing that USDA did for 42 counties. Unfortunately, you can see there that most of them are in northern Michigan, where our southern part, where we have the most intense agriculture, we had the least amount of those common land units. So basically in watershed projects that we fund, we go through and usually digitize the field boundaries for the watershed that we're working in. Like I mentioned earlier, for the Western Lake Erie Basin, the Environmental Working Group has done that, so we have that all done. And as far as the hydro modification, the hydro enforcing, whatever it's called, I'm not the GIS person. That the state is actually paying Michigan State University right now to go through that process within the entire state, for the entire state of Michigan. And we've provided funding to make the Western Lake Erie Basin the first priority, and then Saginaw Bay watershed the second priority for that hydro modification to occur, the DEMs, which, as said earlier, is needed to run the ACPF tool. And so in the Western Lake Erie Basin, our hope is that by the end of probably calendar year 2023, that we will have the ACPF tool run on all of the Huck 12 watersheds within the Western Lake Erie Basin. And like I said, as of right now, it's primarily where the ACPF is being done is where we have watershed planning projects currently being developed through our Non-Point Source program. Appreciate everybody's time, and anybody has any questions, I'd be glad to answer them.
Yeah, thank you. It's interesting to see each state takes a different approach, and that a lot of this is being led by Eagle. Next up, Karl Gesch will provide an example of how Iowa has a real different approach as to where the leadership is coming from for some of this, and for the Root River and Beargrass Creek, those were more much more focused on those individual watersheds, that the energy and expertise was coming more locally. So who it is that runs the ACPF is really varying from state to state.
Yeah, and I will say in Michigan, I mean, our intent is there hasn't been a lot of different people running the tool at this point, but our intent is to get that information all out to the conservation districts, the local NRCS staff, and they will have access to utilize that on the ground. That is not going to do any good if we don't get it out to the conservation districts and the NRCS staff, those people that have the relationships with the farmers and are going to be working with them day in and day out. So
Yeah. Good. On Wendy asks, how did you develop your high priority criteria, the tillage, proximity to water, et cetera? Was it an expert group or data driven or both? And also, how do you plan to target funding to your high priority areas?
So it was basically we some of us within the non-point source program basically sat down, we went through the data, we included we piloted this in one watershed, the Bean Creek watershed in Hillsdale and Lenawee, and we kind of went through the data and talked about it and kind of that red green map I showed you. But there is a number of ways to do that. I mentioned the Lenawee Conservation District starting implementation. The first thing we're going to do is we're going to sit down with them with all the data we have and actually go through it again and see if working with them, is there other parameters, other attributes that we should be looking at to prioritize. I think there is a number of different ways you could, depending on the pollutant you're chasing, there's a lot of different ways you could use this. There is not one way. As far as prioritizing funding, we're trying to use it. The problem right now is I don't think we have enough information. We're just starting to develop all this information. But that is the intent, is to use what's being put together here to prioritize where to focus dollars, and then using the ACPF tool as to what practices and that type. So.
Great. Any other questions? Okay. Well, thank you very much, Thad. And I'll hand off now to Karl Gesch. If you would introduce yourself and dive in.
Thanks, Marcel. Good morning, everyone. My name is Karl Gesch, and I am with the Wisconsin Department of Natural Resources. And I'll be wearing a couple different hats today to share a couple of case studies for how ACPF has been used in the states you see on the slide here, Iowa and Wisconsin. So I formerly worked in Iowa before I came to Wisconsin. So sharing examples from each state to give you some more ideas of how you might use ACPF in the watershed project that you are working on. So I'll start with the takeaway messages here. Use ACPF to prioritize how you do your outreach, how you inform your engagement strategy for the producers and the landowners in the watershed that you're working in. And be creative in how you apply ACPF outputs to meet your watershed specific needs. There's a lot of outputs from the tool, right? And adapting those to meet the local goals and the local needs of both the landscape and the community in the watershed can be a really useful strategy to get the most mileage out of the ACPF results that you're working with. So diving into an Iowa example, Iowa is doing a lot of work to scale up conservation drainage practices. So think of conservation practices specifically designed to reduce nitrate loads in subsurface tile drainage. And it's part of Iowa's nutrient reduction strategy. It's been a priority since that state released their nutrient reduction strategy in 2013. So one key approach that state is using to implement the nutrient reduction strategy is watershed demonstration and implementation projects in priority watersheds. So these blue watersheds are Huck 8 watersheds. Nested within those, there are more local Huck 12 to Huck 10 scale watershed projects where the practices are being implemented more intensively with dedicated cost share dollars and also staff resources to provide technical assistance to farmers and landowners. So that's a little bit of context here. In those watersheds, partners have written and are writing watershed plans And a key component of developing those watershed plans is to engage local partners, but also and especially farmers and landowners. So the folks who manage the landscape and take care of the working lands as a key stakeholder in developing those local watershed plans. And in developing those watershed plans, I think there's kind of a sequence or a set of 3 really important questions that can be addressed. One of those questions is what to do. What practices, what approaches might be appropriate for the watershed, given the landscape, given the agricultural practices and the like. And a key way to address that question, to answer that, is to seek input from farmers and landowners, right? The folks who live and work in the watershed. So involving them throughout the watershed planning process is an important way to help answer this question. The second watershed planning question is how much to do? What level of adoption might be needed to meet local and regional water quality goals, right? So one approach that Iowa uses to help answer that question is to apply the science that underlies the state's nutrient reduction strategy. And finally, the third piece here, where to do it, right? What practices, how much to do them, and where. And ACPF is a really useful tool to help identify where those practices might be adopted across a watershed. So putting those 3 pieces of the puzzle together can be a really insightful way to help develop a watershed management plan that addresses local priorities at the level needed and in the best places. So I'll walk you through an example of how this kind of sequence works to answer those 3 questions. So first, the what question. So in an example from Northwest Iowa, the Headwaters Cedar Creek watershed, a group of farmers got together and participated in a series of watershed planning meetings. And throughout that process, they set their own goals for this small Huck 12 watershed in Northwest Iowa. And those are shown on the screen here. Sustain agricultural profitability in the watershed, reduce soil erosion, and then to reduce nitrogen and phosphorus loads by 41% and 29%. And the context for those 2 numbers, those are the goals for agriculture within the state's nutrient reduction strategy. So the farmers adopted the statewide nutrient reduction strategy goals locally for their own Huck 12 watershed. Second question, how much, what level of implementation might be needed to meet those goals? So I mentioned Iowa's nutrient reduction strategy has a science assessment. And included in that science assessment is a quantification of, on average, how those various practices, conservation practices, are expected to perform in terms of nitrogen and phosphorus load reductions. So just for example, here on the slide is a chart showing the average performance that would be anticipated from the practices shown on the screen in terms of how much nitrogen load they would reduce. The dashed line on the chart is the 41% goal for the nutrient strategy. So as you can see, some practices on average, you'd expect to more than meet that goal at the field scale, other practices, not so much. So knowing that different practices are appropriate in certain places or more appropriate in certain places throughout the watershed, you can start to see how having some practices in some locations and different practices in different locations can help to meet the 41% goal overall at the watershed scale, for example. And then finally, at the watershed scale, where might these conservation practices be adopted throughout the watershed? So ACPF outputs were developed for the watershed using the entire toolbox. And I think another thing to take away here is that there's a lot of opportunities mapped here, right? And probably more than is realistic to ever be implemented. So there's a little bit more refinement that was needed. But another thing to note here is that in looking at each practice individually at the watershed scale, ACPF helps give a sense for landscape capacity, if you will, for what level of adoption might be reasonable to expect within a watershed for any given practice. So that's a way to help ensure that the practices that are recommended in a watershed plan in fact are good fits based on the conditions in the watershed. So putting those three pieces of the puzzle together, the what, which practices are priorities locally, what level of adoption is needed, the how much, and the where, the ACPF results. A conceptual implementation scenario was developed for that watershed. The numbers shown behind each of the practices in the legend are the adoption goals for that watershed over, I believe they set a 20-year time frame, although I would have to double check that for their implementation period. That said, within the first couple years after this watershed plan was completed in late 2016, the local watershed coordinator took these results, did a lot of local outreach and sales of the conservation practices, if you will, and did some great work supporting installation of bioreactors and saturated buffers in particular. So the blue and purple areas on the map. And based on the level of implementation as of a few years ago now, the slide is a bit dated, they were anticipating some really good progress in reducing the nutrient loads from that watershed. And that's continued over the last few years as well. Next, let's pivot to Wisconsin. And
Karl, before you leave Iowa,
yeah,
there's a question here. Who developed the estimate of % load reductions for each practice?
That was based on the science assessment of the nutrient reduction strategy, which I believe was led by Iowa State University scientists.
And have no nutrient loads been measured to corroborate the % reductions expected? Boy, this is the holy grail here.
Yeah, that's a good question. And it's one that farmers asked about in watershed planning meetings too. So there's the lag time, right? And the issue of needing to implement at sufficient scale to be able to measure results in stream. And there's actually been some analysis in Wisconsin that I've seen now that I'm on this side of the Mississippi, suggesting that there is kind of a key threshold of adoption that's needed before results are reasonable to be expected to be seen in the water quality. But to the question, Marcel, if I recall this watershed correctly, I don't think there was monitoring happening for this individual Huck 12. It was happening a little farther downstream for maybe, I want to say 5 Huck 12s. But I've not seen those data since moving to Wisconsin. But I do know that at a local-ish scale, there is some monitoring, or at least a few years ago, there was some monitoring occurring. I will also say that there was some field scale monitoring happening, and that's kind of the intermediate between using models to kind of estimate improvements that we would expect to see, and then measuring in-stream results. So the field scale monitoring is a good way to provide feedback to farmers on the performance of the practices and the reductions that they're seeing based on just their field through installing a bioreactor, for example.
I think this is a good question to keep asking, because ACPF does not do, there's not load reductions as part of the tool, and each user is finding different ways to combine it. You have to combine it with other sources of information, and here's how Iowa was doing it, but each user kind of combines it in different ways to solve that problem of how do we estimate how much we need and what we can get out of the practices.
Yeah, that's a good clarification, Marcel. And I think I view that as really positive because it allows for flexibility for whatever approach has buy-in and support for the state where the ACPF tools are being used. All right, any more questions on Iowa before we cross the Mississippi virtually over to Wisconsin? Okay, hearing none. Let's pivot to Wisconsin, where I'd like to share a case study focused on improving trout habitat. So similar overall approach of identifying a goal and using ACPF to meet it. But in this case, the goal was quite different than implementing the state nutrient reduction strategy. This was to improve trout habitat in local streams. So we're looking at the Wilson and Innis Creek watershed in Dunn County in west central Wisconsin. And ACPF results were applied here for this trout habitat improvement project. So in this case, we just talked about kind of coupling ACPF with other approaches, right? So Wisconsin has a tool called EVAL, that stands for the Erosion Vulnerability Assessment for Agricultural Lands. It also is a GIS-based tool. And what it does is it identifies areas that are at highest risk for soil erosion. And it's a combination of the universal soil loss equation, but also uses the stream power index, and also accounts for internally drained areas to identify the highest risk areas throughout the watershed. So in this case, the local conservation team integrated the outputs of Wisconsin's eval tool with the ACPF tool, particularly the runoff risk outputs, in addition to the potential conservation practice locations, to weave together a more complete picture of the conditions in the watershed. So then using that information, they proceeded to do very targeted outreach to the landowners along the stream, with the priority being the highest risk fields for runoff and soil loss to these streams that were really important for trout habitat. So the result of that outreach was installation primarily of grassed waterways and protection of the riparian corridor along these sensitive trout streams. And they did observe some noticeable improvements in the trout communities in those streams as a result of the habitat work. That's all I've got for the Wisconsin case study. I think, again, I'd just like to remind everyone to think really creatively about the problem or the issues that you're trying to tackle in your local watershed, and use ACPF really strategically and adaptively to help address those local resource concerns.
Thank you, Karl. Some great examples. At our next session on Tuesday, we're going to talk more about how do you format this data. The output from ACPF is it's data. You know, the ArcGIS does this math on individual pixels, and you get this data. So there's a lot of different things you can do with it, as Karl was saying. There's a lot of creative ways to use this. And so on Tuesday, we'll talk more about what kind of maps do you build and what considerations do you put into what you include or exclude on a map, depending who's using it. You know, what scale, what electronic delivery of this information versus hard copies, you know, all of those things. And all depends on what your resource concerns are and who your partners are and how you're going to use that. So we'll talk more then, and we'll also have some opportunities on Tuesday for you to start talking and thinking about how you want to use ACPF, and so you can get some feedback from others on that. Any other questions for Karl or about today's session as a whole or next Tuesday? Okay, anything else from Janice or other organizers here today?
Nope.
Good, well, thank you all. And we will wrap up here 10 minutes early. Again, oh wait, I want to make sure you get that feedback link again, which is in the agenda.
I just posted it in for you.
Oh, good. I will not try to share that. That will be. And again, fill that out at any time. Well, with any questions you might have for any of the speakers, and we'll make sure the right person gets the question. It's also an opportunity to give us some feedback on how this worked as far as helping you understand the ACPF. So we encourage you to give us some feedback on how you would adjust these sessions in the future. All
Thanks,
right.
Marcel.
Have a good afternoon, everyone.
Thank you.